Hello, everyone. Welcome to this month's episode of Additive Manufacturing and Beyond. Today, we will discuss the economics of additive manufacturing in production. Additive manufacturing has already proven its ability to create parts that were once considered impossible. But when it comes to industrial production, the question is less about what can be built and more about whether it makes financial sense to do so. For a factory manager or operations team, the decision to integrate metal or polymer additive systems comes down to economics. Understanding when additive manufacturing outperforms conventional methods such as machining, casting, or injection molding requires more than a simple cost per part comparison. Factors like tooling, downtime, inventory, and time to market all play a role in determining the real return on investment. In most production environments, the first metric people look at is cost per part. Traditional manufacturing processes are optimized for scale. If you are producing hundreds of thousands or millions of identical parts, methods like casting or injection molding are usually cheaper. But this changes when production volumes are lower, geometries are complex, or designs change frequently. Additive manufacturing removes many of the fixed upfront costs. There are no molds, dies, or dedicated fixtures required before production starts. A 3D printer can move from one part to another simply by changing a digital file, without long lead times or additional tooling costs. This makes additive manufacturing especially valuable in production environments where flexibility matters. Instead of focusing only on cost reduction, AM adds agility to the production line, which often leads to better overall economics. At low production volumes, additive manufacturing is clearly more cost-effective. For example, printing a small number of specialized metal brackets for testing or early production is far cheaper than machining them or creating tooling for casting. At this stage, AM works as a bridge between prototyping and full production. At medium volumes, the cost comparison becomes more detailed. Machine speed and process efficiency start to play a bigger role. Dual laser systems, such as the ISLM 350D, can significantly reduce build times and lower the cost per part. When parts are designed specifically for additive manufacturing, AM can compete directly with machining, especially for complex geometries or high-value materials. Post-processing, inspection, and qualification still need to be considered, but the overall cost structure often remains favorable. At high volumes, traditional mass production methods still dominate, especially for simple parts. However, additive manufacturing is often used to support production during ramp-up phases, or when supply chain limitations make traditional production difficult. One of the largest hidden costs in manufacturing is tooling. Designing, producing, and maintaining molds and fixtures requires both time and capital. Additive manufacturing eliminates most of these costs by replacing physical tooling with digital files. Downtime is another important factor. In traditional production, a broken tool or worn mold can stop production until a replacement is available. With additive manufacturing, replacement tools or fixtures can be printed when needed, reducing downtime and lost revenue. This idea also applies to spare parts. Instead of storing large inventories of rarely used components, manufacturers can store digital part files and produce parts on demand. This reduces inventory costs, lowers the risk of obsolete stock, and improves supply chain resilience. Material costs have a major impact on the economics of additive manufacturing. Some AM systems require proprietary materials, which can increase long-term costs and create dependence on a single supplier. Open material systems allow manufacturers to source powders or resins from multiple suppliers, or qualify custom materials. This flexibility helps reduce material costs and improve supply security. Over the lifetime of a production system, material expenses often exceed the initial machine investment, making open systems an important factor in overall return on investment. Many production facilities rely on spare parts with long lead times, sometimes several weeks or even months. By using additive manufacturing, companies can create a library of validated spare parts and produce them only when needed. If a machine fails, the replacement part can be printed quickly, often within a day. This reduces downtime and eliminates the need to store large inventories. Metal printers like the ISLM 350D are well suited for this application, combining production-level reliability with high throughput and consistent part quality. Time to market is a key economic factor in many industries. Additive manufacturing shortens development cycles by combining design and production into a single digital workflow. Design changes can be implemented immediately without modifying tooling or waiting for external suppliers. Additive manufacturing is not a replacement for all traditional manufacturing processes. However, when applied in the right situations, it offers strong economic advantages. The key is to look beyond cost per part and evaluate the full production economics. If you found this useful, give the video a like, subscribe to the channel, and stick around for more content on manufacturing, technology, and the business behind it.